Okay, come, let's start. So find the following indefinite integrals. So over here, integration of e to the power of 2x over 2 dx. So what I'm going to do is, okay, I'm going to take out the half. Okay, put the constant outside, put it half. So half integrate e to the power of 2x dx. Okay, so this is how you integrate exponential. So exponential is very straightforward. It's just keep the same, which is e to the power of 2x over differentiate the power. So to differentiate 2x, you get 2. So the 2 you put it at the denominator. Okay, and because this is an indefinite integral, so you need to remember to put a plus c. So in the end, when you simplify this, you get 1/4 e to the power of 2x plus c. Done. Okay, so just at a side note over here, I will just talk about integration of exponential. So when you integrate, let's for example, e to the power of 3x squared plus 4x with respect to x. Okay, this is, when I write in red, it's just additional information, but it is not related to the question. Okay, so integrate exponential, like I mentioned, we keep the same, exactly the same. Put a denominator means over something. Differentiate the power. So when you differentiate 3x squared plus 4x, you get 6x plus 4. Okay, then don't forget to put a plus c. Okay, don't forget to put a plus c. Then you can write this as, take it out. So you can write it as 1 over 6x plus 4 e to the power of 3x squared plus 4x plus c. And because again it's indefinite, indefinite means you see that I don't have numbers that don't have limits to sub in. You must remember to put a plus c. If you forget to put a plus c, the school will minus mark. The school will minus mark. So I'm going to box this up because this is additional information. Okay, let's move on to the next one. Okay, integrate 4 over x plus 1 over x squared dx. So I'm going to split this because this is two separate terms. So I'm going to integrate, I can take out the constant 4, 1 over x with respect to x, plus integrate, this one I'm going to put it in the index form, which is x to the power of negative 2 with respect to x. Okay, so take note that every time when you integrate x to the power of negative 1, thanks for the fire, x to the power of negative 1, it is related to ln. Okay, at the side here, I will say, I put here, when we differentiate ln x, okay, we will get 1 over x. So likewise, when I integrate 1 over x, I will get ln x. Okay, so side note here, if I'm going to differentiate, let's say ln 3x plus 5, okay, we will get 1 over 3x plus 5 multiplied by differentiate the inside, which is 3. So it's times 3. So we put it as 3 over 3x plus 5. Done. This is differentiation. Don't get confused. This is differentiation. So this is how you do this kind of question. Then when I do integration, okay, so let's see here. If I'm going to integrate 1 over x with respect to x, you will get ln x plus c. Okay? If I'm going to integrate, let's say 3x plus 5 dx. Okay? This one, minus 1 over 3x plus 5. Okay, you know that you can change it to the power of negative 1, right? But take note, to the power of negative 1, when you integrate, it is related to ln. Okay, so you will get ln 3x plus 5 over differentiate the inside, which is 3. So put it at the denominator. Then remember to put your plus c. Okay, so basically this is differentiation and integration that's related to logarithm. Okay, so let's continue. So this one is 1 over x. So over here I have mentioned that when we integrate 1 over x, it is ln x. So this one is just 4, then you just put ln x. Okay, plus This one, x minus x to the power of negative 2, you will integrate as per normal, whereby the power plus 1, okay, take note, power plus 1. So minus 2 plus 1 is negative 1. So it's minus 1 over the new power. So it is negative 1. And don't forget to plus c. Then you cannot leave in this form. You need to simplify this. So you will get 4 ln x minus 1 over x plus c. Done. Okay, so this is how you do integration for this question. Okay, let's move on to the next question. So for a function f, blah, blah, it is known that blah, blah. Okay, this one looks very complex, but you must know how to read the language. So they put f prime x. So you need to know that f prime x is the same thing as dy dx. It's the same thing. F prime x is the same as dy dx. Okay, so fx is the same thing as y. So you need to know the language. If we talk about y, then to differentiate y, you write it as dy dx. When I tell you that the algebra expression is fx, then you got to tell me the differentiation is f prime x. Okay, so this is the language. Oh no, it's okay because the kids doesn't learn modulus, so we can actually no need to bother about the absolute. Okay, so for a function f, okay, so over here f prime x, so you can rewrite this as, so I can write this is okay, I write here so that it's easier to see. F prime x, they wrote it as 2x plus 1 over square root x. Then they tell us the additional information is f9 is equals to 90. They want you to find what is fx. So this is dy dx. So actually what they want you to do is you are supposed to integrate. Okay? But before I integrate, I'm going to split this first. Because you can see that the denominator is only one term. So it will be 2x over square root x plus 1 over square root x. Wow, thanks. Thank you. Okay, so then we need to simplify. This is half, x to the power of half, so it's 1 minus half. Okay, so it is 2x to the power of half plus x to the power of negative half. Okay, you will have to split it into this form first. Then now it's easy for you to integrate. So now I would like to do my fx, which means that I'm supposed to integrate 2x half, okay, dx, plus integrate x minus half dx. Okay, so this is how you integrate. The two constant, I put it outside. Power plus 1. Half plus 1, so it's 3 over 2. So it will be x 3 over 2 over the new power, which is 3 over 2. Plus. Yeah, I understand that this one have to put plus c, right? But it doesn't matter because this one got plus c, this one also got plus c, and then in the end it will still plus a constant. So I don't have to write, I only need to write 1 plus c at the back. Okay, so now this one. Minus half plus 1 is half. So I get x to the power of half over the new power, which is half, and then put a plus c. Okay, 1 divided by 3 over 2, it is 2/3. So it becomes 2/3 times 2, which will give us 4 over 3. X, 3 over 2. Okay, and then this one will be 2 x to the power of half plus c. Okay, so this usually we will present it in the surd form. So you will write it as 4/3 square root x cubed. Denominator 2 is square root. Cube is here. So 2 square root x plus c. We're not done yet because you're supposed to find fx. Okay, complete fx. But now I still have an unknown c. And that is one, they give you an additional information. F9 is equals to 40. So we're going to find our F9. It means that I'm going to sub in x equals to 9 into here. So it will be 4 over 3, 9 cubed plus 3 square root 9 plus c. And we will get 4 over 3, 27 plus 2, 3 plus c. We get 42 plus c. And you will say, okay. Therefore, 42 plus c will be equals to 40. Okay, equals to 40. And you will get c equals to negative 2. Now, c is found. So you can write the full fx. So therefore, fx is equals to 4/3 square root x cubed plus 2 square root x minus 2. Done. Yes. Okay, let me explain to you why you need to plus c. Okay, I ask you a question. You see, when I have, let's say, y is equals to 3x squared plus 5x minus 5. Okay, my y is here. Let me explain to you why if you did not put plus c, it is wrong. Okay, you see, when my y have 3x squared plus 5x minus 5. So I'm going to differentiate this one, dy dx. I get 6x, I get 5. And when you differentiate a constant, you get 0, it disappears. Agree or not? So, it means that if I'm going to integrate my 6x plus 5 with respect to x, okay, now I work backwards. I get 6, okay, then this one x squared over 2 plus 5x. You see, the original y has a constant there. When you differentiate, it disappears. So, when something disappears, doesn't mean that the original y does not have a constant. So, you need to put the plus c. You need to put a plus c because there's a constant there. Whether is it 0 or not, it doesn't matter because we need to acknowledge and say that, oh, my y might have a constant, so I have to put a plus c. So, 3x squared plus 5x plus c. And that is why integration, they always give you one more additional information. They will tell you, okay, your curve passed through a point, or, then you will sub in the point into it. So here this is y equal, y equal, y equal. So usually they will give you a point, you sub the x and y, and you will find the unknown c. You understand? So if you do not put the c, okay, it means that your fx is already wrong with you. You understand? Okay, so this is why you must remember why you need to put plus c. Okay, so this is for question 2. Question 2, again, I'm going to box it up because this is not related to the question, but it's additional information. So for those who are new here, okay, so you should know that by now, not by now, my bio has the link. Go to the last button, you can go to my Telegram channel. So my PA Sam will actually upload the worksheet plus the solution, okay, and also upload the TikTok live video on the YouTube channel. Okay, so my bio, 2 buttons, the last 2 buttons, one is to go to my YouTube channel, one is go to my Telegram channel. Telegram channel is to get the PDF worksheet. YouTube channel is to see the recording. Like for example, today, if you feel that, okay, I'm talking too fast, you cannot catch up, you want to revise again, you want to refer it to it again, okay, wait for tomorrow when Sam uploaded the PDF worksheet, you can try the question yourself, or you can go to the YouTube channel and revisit the video again and learn again. Okay, so today I speak about it, so maybe you can understand 60 to 70%. It's fine, it's fine. Okay, then after that, when you revisit it again and try the question again, and that's where you will really learn the more to 90% of the thing, of the topic already. This is how you should learn. Okay, let's move on to the next question. Question 3. So this is one that is related, as in like, because our integration do not have many rules, okay? It does not have a lot of rules. So a lot of times you might have to do differentiation first and make use of the differentiation to do the integration. This is what I call the reverse, okay? Reverse. So over here you can see this question. Part 1 asks me to differentiate this. Then part 2, they say, hence, find the integration of this. Okay, there is no way you can do integration of this, okay, without doing the differentiation. Understand? So this is called the reverse. So let's take a look at the differentiation first. So I'm going to differentiate x cubed ln x. Okay, you can see that this is x cubed multiplied by ln x. So it is an expression multiplied by an expression. So when you want to differentiate, you will have to use product rule. So we will have keep left, which is I'm going to keep x cubed, differentiate ln x just now I have tell you, which will be 1 over x, plus keep right, which is ln x, and differentiate the left, which is 3x squared. So x cubed times 1 over x is x cubed divided by x, so it becomes x squared. This one, you usually put it in front of the ln x, so you will rewrite this as 3x squared ln x. So this is pretty easy, it is this way. This is how you differentiate x cubed multiplied by ln x by using product rule. Now next, hence find the blah blah blah. Okay, so every time when they come out this kind of question, what you need to do is you need to write for me the reverse. If I differentiate this, I get this. It means that I integrate this. See, it means that when I integrate x squared plus 3x squared ln x with respect to x, I get this. Agree? So you must always remember to write this reverse thing. And don't forget, because this is indefinite with no limits, so put a plus c there. So what I did was, I just write the reverse. When I differentiate this, I get this. So I will write it as, when I integrate this, I get back the y. Understand? So write this, and then after that, you look at the question here. They want to find out integrate x squared ln x. So if you notice here, it is actually here. Here. It is actually this portion. So I need to massage a bit. Okay, let's massage a bit. So here, I'm going to write it here so that it's easier for you to see. So it will be integrate x squared dx. I split. This is 2 terms. So I split it. So integrate x squared dx plus 3 integrate x squared ln x dx is equals to x cubed ln x plus c. You see that? So what I did was, I split this into 2 terms. I take out the constant 3 and put it outside here. Okay, so there are 2 terms here. This first term, you can integrate as per normal. So it will be x3 over new power. This one just copy because we are not able to integrate this one. We just put it there. So now your objective is to make this the subject. Okay, make this the subject. So I'm going to bring this to the right hand side. So it will become 3 integrate x squared ln x dx is equals to x cubed ln x minus 1/3 x cubed plus c. Okay, this is 1/3 x cubed. I'll bring over, become minus 1/3. And the question asks you to find integrate x squared. But over here, this is 3 integrate x squared. It's like this. They're asking you to find 1 unit. Currently now it is 3 unit. So all I need to do is just divide by 3. So divide by 3 is the same thing as multiply by 1/3. So I'm going to divide by 3. So I will get integrate x squared ln x dx is equals to 1/3 x cubed ln x minus 1 over 9 x cubed plus c. And we're done. You see that? This is an important question. They will always come out this kind of question, which is you need to differentiate, use a reverse, and do the integration. And a lot of times, the reverse, they will have like more than 1 term. So for this case, there's 2 terms. 1 term you can integrate as per normal, so you integrate it as per normal. And 1 term will be the object, will be the term that you are interested in. Okay? But for this case, it's times 3. So it's okay, we can just make it the subject first. Then the one that you integrate as per normal, you're going to bring it to the right hand side. Okay, bring it to the right hand side. After that, because this is 3 unit, divide by 3, you'll get 1 unit. And ta-da, you are done. So this is how I do the reverse. Okay? Of course, some students, some of my students very link. You go to my bio. Go to my bio, my TikTok bio, there's a link. There's only 1 link there. You click on it. There's many buttons there. The last button, join my Telegram channel. So all the past PDF for the TikTok is there. So this will be this kind of question. Yes, in my Telegram. Okay. Okay, so now let's move on to the next question. And now, partial fractions. So partial fraction is a topic whereby they teach you in Set 3 AMath. Okay, which I think few TikToks live I teach about partial fractions. So basically it is you are splitting single fraction to their individual fraction. In AMath you combine into a single fraction. In AMath you do the other way around. Okay, so in integration you will make use of partial fraction to do integration. It's a commonly asked question. So there's no way you can run away from partial fraction. Okay, yes. So now take it as a chance to recap your partial fraction. So let's take a look at this. I'm going to write the question here. So it's 5x plus 9 over 2x plus 3 and x minus 1 squared. First, if those who were here with me who learned partial fraction, what is the first thing you need to check first? What is the first thing you need to check for partial fraction? Okay, let's see who is my regular and attentive student who can help me. Whenever you do partial fraction, what is the first thing you need to check first? Whether is it what or what? Well done. Okay, you need to check whether is it proper fraction or is it improper fraction. Okay, so to check is look at the denominator. The highest power after I expand I will get x cubed. Yes. Then the numerator is x. So my numerator degree is smaller than the denominator. It means it's a proper fraction. So if it's a proper fraction means I do not need to do the long division. I can proceed to apply my case 1, case 2, case 3. Thank you. Okay. Okay, so over here, let's take a look at my denominator. I have a linear, which is case 1. I have a repeated linear, which is case 2. So this will give birth to a over 2x plus 3, b over x minus 1, and c over x minus 1 squared. 2x plus 3 will give birth to 1 fraction. The repeated linear will give birth to 2. 1 with to the power of 1, 1 to the power of 2. After that, you need to combine this into a single fraction. So denominator, this is, I have to multiply it with x minus 1 squared. This one I have to multiply with 1, 2x plus 3 and 1x minus 1. The c I have to rainbow with 2x plus 3. The whole thing over 2x plus 3 and x minus 1 squared. So then after that I will have to do our compare. So it will be 5x plus 9 will be equals to a x minus 1 squared plus b 2x plus 3 x minus 1 plus c 2x plus 3. Okay, limited space here, so a bit untidy here. Okay, so I will sub suitable value, okay, because I will find it very tedious to rainbow the right hand side. So I will use suitable value. So I will sub in x equals to 1. When I sub in x equals to 1, I will make my a disappear, my b will also disappear. So then I will left with my c, okay. So I will sub x equals to 1. So I will have 5, 1 plus 9 equals to c 2 plus 3. Okay, because this one disappear, I don't have to write anything. So it's 2 times 1, which is 2, 2 plus 3, which is 5. So I end up having 5c is equals to 14. So my c is 14 over 5. Okay, so yes, we should panic. We should panic when you get a funny number. In this case, it's a funny fraction, right? Then you should check whether you make any mistake. But if you are 100% very confident that you do not make any mistake, then you can just proceed to do. Okay. Next, I have solved my C. So now I'm left with A and B. So I can now sub in negative 3 over 2 because I have the bracket 2x plus 3. So I'm going to sub in minus 3 over 2. So if I'm going to sub in minus 3 over 2, my C disappear, my B disappear, but my A remain. And I can solve my A. So I'm going to sub in, here. I'm going to sub in x is equals to negative 3 over 2. 5 negative 3 over 2 plus 9 is equals to A minus 3 over 2 minus 1 squared. Because my B disappear, my C disappear, I left with the A. So I ended up having 25 over 4A is equals to 3 over 2. Wait Okay. This is integration. So let's come back to here. Sorry, I got a text. A is equals to 6 over 25. Okay, now we left with B, right? So you see, I have my A, I have my C. I only left with unknown B. So you can sub in any x value, any x value. So now I'm going to sub in x equals to 0. Let's sub in x equals to 0. So I will have 5, 0 plus 9 is equals to 6 over 25, 0 minus 1, plus B, 3 minus 1, plus 14 over 5, 3. Okay, yes. Okay, then after that, I will have my 9 is equals to 6 over 25 minus 3B plus 42 over 5. And eventually, I get my B is equals to negative 3 over 25. So I have my C here, I have my A here, and I have my B here. Okay, so I will write it as, therefore, okay, so in this case, when they ask you to integrate, see, they ask you to integrate 5x plus 9 over this. And check, this is exactly the same as this. Okay, this is exactly the same as this. It means that to integrate this, I just need to integrate the partial fractions. So I will write it as, when I integrate 5x plus 9 over 2x plus 3, x minus 1 square is the same as integrating a over 2x plus 3. So my a is this. So it's 6 over 25 2x plus 3 minus my b is negative 3 over 25. So it's 3 over 25 x minus 1 plus my c is 14 over 5. So it is 14 over 5 x minus 1 squared. Got it? So this is one part whereby you will use your partial fraction. Just now I already mentioned that the question will only be posted tomorrow after the TikTok live, okay? Because I will have to go through the question first, write the solution, then my PA will upload to the Telegram channel the worksheet with the empty space in front, the first few pages, then the solution behind. It will not be uploaded now, okay? What you can do now is use a PC to learn, okay? Screenshot whatever you need to screenshot, or you can refer to the YouTube channel after that. Okay, so now we can proceed to integrate this. So remember, when we integrate anything to power of negative 1, it is related to ln. So I will write this as, this will be 6 over 25 integrating 1 over 2x plus 3. Okay, this is this. Then this will be 3 over 25 integrate 1 over x minus 1 dx. Okay, this I will write it as plus 14 over 5 integrate x minus 1 to power of negative 2. So the first term, when you integrate, is related to ln. The second term, when you integrate, is also referring to the ln. But for the third one, you will just integrate as per normal, whereby power plus 1 over the new power. So this will be, you will write it as ln 2x plus 3 over, differentiate the inside, which is 2, put it at the denominator, understand? Okay, 3 over 25, this one will be ln x minus 1 over, differentiate the inside, which is 1, although it's a 1, but just put it there to show the teacher that, oh, I know that I need to differentiate the inside, put it at the denominator. Okay, and then put a square. This 14 over 5, so this one power plus 1, minus 2 plus 1, so it's negative 1, over, they got two numbers that I got to put at the denominator. First number is the new power, which is minus 1. Differentiate the inside, although the differentiate inside is 1, so put 1. So actually there's two numbers you need to put it at the denominator. First is the new power, whereby it is the old power plus 1, so it's negative 1. New power, put it at the denominator, multiply by differentiate the inside, which is 1. Okay, and don't forget, this is a plus c. Yes, no. If the power is not negative 1, then you will integrate it as per normal. Power plus 1 over new power. Okay, when your power is negative 1, then it will be ln. Okay, so let's simplify. So this one will be 6 over 25 ln 2x plus 3 minus 3 over 25 ln x minus 1. This one, I will write it as a minus. Okay, minus 14 over 5, 1 over x minus 1 plus c. And of course, it doesn't look nice with the 14 over 5 written here. So what I'm going to do is, we can just put this one as 14. Wait, 5. Right? And we are done. Okay? So, just take note that for the answer sheet, okay, what they did was, because, oh, I forgot one thing. Just now the 6 over 2, this one should be 3. Because 6 and 2 cancel, this should be 3. So you can see that both of them have 3 over 25. So we will take out 3 over 25. I will have ln 2x plus 3 minus ln x minus 1 minus 14 over 5 x minus 1 plus c. Yes, sorry. I missed out the 2 just now. First question, you must rewrite the fraction with the value you found in. First question, you must rewrite the fraction with blah blah blah. Yes, correct. So, Ashwin is, yes, he's right. He is right. Because for part 1, they asked us to express this in partial fraction. So, after I find my A, B, C, okay, remember that you need to write this as well. Okay, let me just put it here. So, you will say, therefore, my 5x plus 9 over 2x plus 3 and x minus 1 square is equals to 6 over 25 2x plus 3 plus b is minus. So it's minus 3 over 25 x minus 1 plus 14 over 5 x minus 1 square. Oops, my square goes to my next paper. Wait, yeah. Okay, so what he means is you need to express this in partial fraction. Okay, this part this, you see, part 1 got 6 marks already. Okay, so we are not done yet. What I did was I take out the common factor 3 over 25. Okay, and you must know that logarithm is when you have the same base and it's minus, it becomes divide for these two. So you will rewrite as 3 over 25 ln 2x plus 3 over x minus 1. Okay, I have two moderators in the chat. So if you speak weird things in the chat, I have no control over the moderator. So these two moderators are people who I trust with my heart. So whoever they block, I don't check. Okay, so I will leave it to them to decide who to block. Okay, so this is blah 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 blah, and we're done. This is blah 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 blah. Yes, don't need to bother about the absolute thing. We don't write in absolute in secondary school syllabus. They took it out the modulus, so it is fine to just put bracket. It's fine to just put bracket. Okay, so that's all for this question 4. Okay, it's making use of partial fraction to do integration. Okay. Teacher, explain the individual integration I just joined. Is there any case that you don't need to add c? You don't need to add c when it is a definite integral. Means that there is a limit. Okay, limit. That means there is a number in between, like 3 and 2. Then you will have to sub in the number. And when you sub in number, there will not be any plus c. That's definite integral. Okay, but we are doing indefinite integral today. So you will have to put plus c. Okay, so okay, I cannot explain the whole everything again. But I will just roughly talk about this side. When I want to integrate 1 over 2x plus 3, because this one is to the power of negative 1. So to the power of negative 1, when you integrate, it is ln. Okay, so it will be ln 2x plus 3 over differentiate the inside, which is 2 at the denominator. Okay, same apply for integrating this 1 over x minus 1. Because it is x minus 1 to the power of negative 1. And when you want to integrate to the power of negative 1, okay, you will be ln x minus 1. Yeah, you can actually refer to the TikTok live again. Okay, so then next thing is I want to highlight on this part. So x minus 1 to power of negative 2, when you want to integrate power plus 1 over the new power multiplied by differentiate the inside. Okay, this is how you integrate the normal integration. This is a normal integration. Which ln is f? No. I don't understand. Okay, so I'll move on to the next question. Okay, differentiate ln x is 1 over x. Integrate 1 over x. Come start this chapter with this week. Okay, come. Oh, two more questions for the day. Okay. Show that differentiate this one is okay. There is a slight tricky part on this question. Although you say, it's so easy, no problem. Okay, let's take a look. First, okay, I'm going to differentiate x squared ln x plus 1. Okay, take a look at this one. This is x squared multiplied by ln x plus 1. It means that I have to use product rule. So it will be keep left, differentiate ln, which is 1 over x plus 1, multiplied by differentiate the inside, which is for this case is 1. Plus, keep the right, which is ln x plus 1, and differentiate the left, which is 2x. Okay, don't have plus here. This is differentiation, it's not integration. So you need to be very careful. Yeah, I also don't understand what is the teacher teach. Ln is f prime x over fx. Yeah. Okay, so after that, let's take a look. So we're going to simplify this. So it will be x squared over x plus 1. Okay, plus 2x ln x plus 1. So now the question is, you are supposed to prove this to be this. Now you compare. Yes, I do have the 2x ln x plus 1 over here. But this and this is not the same yet. So don't tell me it's shown already. It's not yet shown. It's not yet shown. Yeah, actually there's no other method. Actually differentiation of ln x is fixed. And differentiation of exponential is also fixed. So I also don't understand. Maybe, yeah. Okay. Okay, now let's see. So your task, okay, the trick is, look at this question over here, this part, and see how are we going to simplify to here. Okay, so what I'm going to do is, I'm going to put here, so we can do additional working here. So this is the whole thing is x minus 1 over 1 plus 1 over x plus 1. So I shall combine this into a single fraction. I shall combine this into a single fraction that will give us same denominator x plus 1, so it will be x minus 1 times x plus 1 plus 1 over x plus 1. Then this one, if you notice, this is a minus b, a plus b. So it is actually a square minus b square. So it will be equals to x square minus 1 plus 1 over x plus 1. You see minus 1 plus 1 is 0, right? So it end up become x square over x plus 1. You see now it's exactly the same? No, I didn't do long division. What I did was I combined the single fraction. Because your task is to show differentiate this one is this. So I did my differentiation, which we get here. But yet, I haven't proved that it is the same as this. So from the x squared over x plus 1, it's not possible to see, you see. So what I do is, I work backwards. I come to here, I do my combine into a single fraction, blah blah blah. Then I see that, oh, actually they are making use of the x squared minus 1. So what I'm going to do is, I'm going to do a little bit here. So this x squared, I will do x squared, I will put minus 1 plus 1. Because when I do minus 1 plus 1, no effect. It is still a 0. So now, this one put like that. And this is x plus 1, x minus 1 over x plus 1 plus 1 over x plus 1. And this, I can cancel this. And so in the end, I get x minus 1 plus 1 over x plus 1 plus 2x ln x plus 1. Done. You get that? Okay, so this is 3 marks. This is only differentiation. So, you may ask me, why are we doing this differentiation when we are doing integration? And like I say, a lot of times, we have to make use of the differentiation to do our integration. So let's take a look at this one. Integrate x ln x plus 1. So now you look at the question, go and find whether you can see x ln x plus 1. And it is here. Okay, it is here. So remember, we need to write the reverse. Write the reverse. So now it means that I will say, oh, okay, when I integrate this whole thing, x minus 1 plus 1 over x plus 1 plus 2x ln x plus 1 dx, it will give me back my y, which is this one. X squared ln x plus 1 plus c. Okay? So you see here, okay, so kids, if you are doing exam, if you are right, you do until here, you are stuck. Okay? Please don't just stop there, because you already have differentiate, this become this. And for the part 2, you can straight away know that, oh, that means I will just say integrate this part, will give me this part. And you still can do the second part. You understand? You still can get your 4 marks. Don't just stop there when you cannot, you are stuck at this part. Okay? So, now let's proceed to, let's take a look at this one. Okay, I can integrate this as per normal, integrate this as per normal. Only this one I cannot integrate, but it's fine. This is what this is x ln x plus 1, 1 unit. This is 2x ln x plus 1, 2 unit. So eventually, my objective is make the 2 unit the subject first. So let's proceed to integrate this as per normal. So this is just x2 over 2 minus x. This is to the power of negative 1. So this is actually ln x plus 1 over 1. This one, you can just put it as integrate. I put the 2 outside. X ln x plus 1 is equals to x squared ln x plus 1 plus c. Okay, now I'm going to make this one the subject. So it will be 2x ln x plus 1 dx is equals to, you can write this first, x squared ln x plus 1. This one I'm going to bring over. This is half x squared. So if I bring over, it becomes minus half x squared. Minus x bring over plus x. This one become minus ln x plus 1. Okay, and don't forget the plus c. Lastly, I want 1 unit, right? So I just need to do my divide by 2. So it means, oh, my integrate x ln x plus 1 dx is equals to, divide by 2 means half. So I can write it as half x squared ln x plus 1 minus half times half is 1/4. So it's 1/4 x squared plus half x minus half ln x plus 1 plus c. And we are done. Okay? So this is how you use the reverse, okay, to do the integration again. Okay, let's move on to the last question. Okay, 3 go. A little bit of 3 go. Integration of 3 go. So I'm going to write the question here. Integrate 3x4. I'm going to split dx minus integrate 5 cosine 6x dx. So my why you yucks? Integration 3 go is fun. It's actually very straightforward. Okay, take out a constant 3. So 3 integrate x4 dx minus 5 integrate cosine 6x dx. So I'm going to write at the side to recap. When we differentiate sine x, this differentiate, we have our cosine x. When we differentiate our cosine x, we have our minus sine x. When we differentiate our tangent x, we have our secant square x. Okay, now let's take a look about the integration. So when I integrate sine x with respect to x, I get minus cosine x plus c. When I integrate cosine x dx, I get sine x plus c. When I integrate secant square x dx, I get tangent x plus c. Okay, so this is for differentiation. This is for integration. So come back to here. Integrate x4 is as per normal, whereby the power plus 1 over new power. So it is just 3x5 over 5 minus 5. Okay, see, integrate cosine, give me sine. So I will write it as sine 6x. But don't forget that this is slightly different. That this is 6x, but this is x. So I need to differentiate the theta, which is 6x, which will give me 6. So put it as a denominator, which is over 6, plus c. And that will give us 3/5 x5 minus 5 over 6 sine 6x plus 6. Okay, done. So this is how you integrate 3 go related. Okay, let's move on to the last one. Okay, so it's still the same. Actually, basically integration of 3 go. You just need to remember to differentiate the theta and put it at the denominator. So I'm going to integrate sine x dx plus integrate secant square 5 plus 2 pi x dx. So integrate sine x, it will be minus cosine x. So I will have minus cosine x over, actually just the action, you need to differentiate the theta, which is 1. So just put over 1. Make it a habit, understand? Okay, next. Integrate secant square is tangent. So it is tangent 5 plus 2 pi x over, differentiate the inside. Okay, differentiate 5 is disappear, differentiate 2 pi x is 2 pi. So you put 2 pi at the denominator with a plus c. So we write, so it will be minus cosine x plus 1 over 2 pi tangent 5 plus 2 pi x. And we are done. Okay? So this is how you do integration of trigo for these last two parts. Okay? So I'm pretty much, in fact, I'm done with the question today.